Okay, so investigation 8. We're going to start with, okay, the first question here is 1. Consider the function f of x equals 2x plus 4. So this is recognizably a linear function. The first question is to explain why f has an inverse function, f minus 1. So why does the inverse function exist? And the answer is Jacob. Yeah, yeah. So we have a linear function. If you invert it, you will also have a function because they are one-to-one, right? And then the big job begins. We're going to complete the table that we find here. So, yeah. So we start off with a column of x values. And the first one we can put in, skip a row, skip another row, and then 0, 1, and 3. I'll just pause this and fill out the rest of the pre-entered information. Right, okay. I'll continue a little bit. So we've started to fill out this table then. And what we can see here is that there is a relationship between x and y values here. So x values and function values. This bit over here looks a bit mysterious. Yes? Yeah. And we read this as the image of 1 under the function f is 6. The image of 6 under the function f minus 1, or the inverse of f, is 1. So that's how we would translate this bit here. The image of 1 under f is 6. And here we can read off the coordinates of a point. The point E of this function has the coordinates 1, 6, and we can plot that point. So the point 1, 6, 2, 4, 6, that's going to be over here. So this is the point E with coordinates 1, 6, right here. And it's really the same information. We say that the image of 1 under the function f is 6, which means that the function value is 6 when the x value is 1. So it's just a different representation of what we already know as coordinates for a point that we can get from a function. Now, further along the table here, we can see the function is being inverted. So the image of y under the inverse function is x, which is the opposite operation of the image of x under f is y. So we're going backwards. So the image of 6 under the inverse function is 1. And we get an inverted point as well. So this is the inverse function, and we can plot this point. So we can read this as E marked. So it's not the same point as E, but it has something to do with E. And it has the coordinates 6 and 1. So we'll plot that 1, 2, 3, 4, 5, 6, and 1. So this is the point E marked 6, 1. So now we've been through what the elements of the table mean, and now we need to fill out the rest of the table. So the principle for getting the y values, if we know the x values, is just to use the function 2x plus 4 to get the function values. If we take 0, for example, f of 0 equals 2 times 0 plus 4, so that's going to be 4. F of 3 is 2 times 3 plus 4, which is 10. So the y value down here is going to be 10. When we look at this column, you should try to do them one at a time. So we say that the image of minus 4 under the function f is minus 4. And this is just to get a sense of what these symbols mean. So the image of 0 under the function f is 4. All right, so we encounter another problem here. What about these x values that we don't know, but we have the function values? So the way to tackle those would be to, well, we know that the function is f of x equals 2x plus 4, right? So we know the function value, minus 2, but we don't know the x. So we can set up this equation here. Minus 2 equals 2x plus 4. And we have to solve this for x. So we're allowed to do the same thing on both sides. We can subtract 4 on either side. Minus 4, and that gives us minus 6 equals 2x, and x equals minus 6 divided by 2, x equals minus 3. So when the function value is minus 2, x is minus 3. So I can write minus 3 over here. We do the same thing with 0, and we get minus 2 as the x value. In the fourth column, these are the coordinates for the points, and now we can just fill in the missing numbers. We use the x values and the function values. Yep. Yep. When we look at the inverted images, we do that in the same fashion. We try to do them one at a time just to get a feel for the process here. So the image of -2 under the inverted function is -3, etc. We also put in the coordinates for the inverse points, the points for the inverse function. So we have finished the table. It's time to draw the graphs of these two functions. And two of the points are actually the same. So this point A on our function f is similar to the point A marked. So the 2 points have the same coordinates. So -4, -4. So we could put that in. Should be about here. Come on. More or less. That's it. A A -4, -4, and A marked -4, -4, like that. Okay. Let's try to draw a straight line from here to here. It's not too bad. Okay, right. So that's what it's going to look like. And that's what you've drawn as well, right? Okay. So what can you say about the type of graph f minus 1 is? Well, the answer to that type of graph, it's a linear, yeah, it's the graph of a linear equation. So it's a straight line. And how would you find more points on this graph? Yeah, you can see from the graph. I mean, if you have a grid, a square grid, then you can use the graph to find more points. Yeah. So, for example, a bit difficult from my sketch, but -1 when x is -1, this graph appears to go through. Sorry, when x is 2, this graph goes through -1 on the y-axis. So coordinates here would be 2, -1. Looks like it, yeah. But you can always check that with the function itself. So next question. What can you say about the position of the point B marked with respect to the position of the point B? What about the position of C marked with respect to C? I mean, we could sort of answer this more generally. What can you say about the position of one graph in relation to the other? They're not parallel. They're not perpendicular to each other, but they have a certain angle between them. But perpendicular would mean a 90-degree angle between them. If they ran parallel, they would look like this. They would never cross, but they do cross. The next question might be key to answering this. So there's one point that lies on both graphs. What is it? Right, the point -4, -4. And what do you notice about the coordinates of this point? They are indeed the same. Right, so so the x and the y coordinate is indeed the same. And what we can also notice is that there is a straight line that bisects.
Excuse me,
Yep.
I can't see anything.
You can't see anything. I'll just share the screen. Do that again. Let's see. Slight delay here. There. Okay. So if we took a straight line going from -4, 4 through the origin, we can see that this line cuts these two parts in half. It runs right down the middle. Now, this line is what we call the identity line. It's called identity line because the x value is always equal to the y value. So every point on this line has the same coordinates, so 1, 1, 2, 2, 3, 3, 4, 4. And for linear equations, this is always the case with the inverse function, that it's mirrored around the identity line. So we are equipped to answer question G. Now explain how you would draw the graph of f minus 1 if you are given the graph of f. All right, so if you want to draw the graph of an inverse function, you can actually use the identity line to just mirror the image of one graph around the identity line. And this is also part of the reason why we talk about the image of x under the function f, for example, is that we project the image across or through the identity line. So it makes sense to talk about a projection then. It's a mirror image around the identity line. Question H. Yep. Yeah. Explain how you would draw the graph of f minus 1 if you are given the graph of f. That's more of a general question, so it's not specific to anything here. The diagram on page 234 is for question 2, and we're not going to go through that. But H, what is the equation of the inverse function f minus 1? There's two ways of going about that. Suggestions? For how to find the inverse function? Right, so let's say, okay, we started out with y equals 2x plus 4. If you want the inverse function, what do you do? All right, so you want to isolate x and express it through y. Yep. So y minus 4 equals 2x. And that gives us y equals 1/2. So x equals 1/2 y minus 2. Right? Another way to do it would be to use the point gradient formula. Y minus y1 equals m multiplied with x minus x1, and then we could use 1 point on the graph. For example, 4, 0. So we could use the point 4, 0. So y minus y1 would be y minus 0 equals m, and then x minus 4. And what is m? Well, m is going to be the gradient of the inverse function. If we write the gradient of the original function as a fraction, we can simply flip it upside down. So this is the gradient for f. MF, it does not stand for what you think it stands for. MF minus 1, we just invert it, so it's 1/2. So y minus 0 equals 1/2, and then x minus 4, y equals 1/2 x minus 2. A third option would be to consider the point, well, okay, we know that the point 0 minus 2 also lies on the inverse, the graph of the inverse function. So 0 minus 2, this is a point on the inverse. So, when y is when x is 0, we know that the function value is minus 2. Which means that if we have a function on the form mx plus c, we know that the c part is going to be minus 2. And since this is an inverse function, we know that the gradient is going to be inverted, the gradient for the original function. So we can write this as y equals 1/2 x minus 2, or if you like, x equals 1/2 y minus 2.